All right, we are doing 12.6 today. 12.6 is on the equation of a circle. All right, so before we get into that actual part of the lesson, we have to do the start thinking part first. And it says a locus is a way of describing an object as all points that have a certain characteristic. We had already discussed this before, but try to remember. How do we define a circle as a locus? It would be all points what? Okay, beautiful. So if you take every single point that is a certain distance from the center, so maybe every single point that is 1 inch from that center point, it would give you this circle. Now you need to make sure that is in 2D. So we already have the fact that a circle is just all points equidistant from a point on a plane. Now before we get into that, I want to remind you about some stuff from Algebra 1. In Algebra 1, you guys studied lines. The parent function for a line is y equals 1x. That means it has a y-intercept of 0, goes up by 1, over by 1, up by 1, over by 1, and so on. As you start changing the m value and the b value, it will shift it up, down, left or right, flip it upside down, make it steeper, less steep. So as you adjust these numbers, the actual object, the line, will change. Then after that, you learned about quadratics. Here was the form that you guys studied in quadratics in, y equals ax squared plus bx plus c. You should have learned that as you go over and change your b value, it's going to be shifting it left and right. As you change your c value, it's going to shift it up and down and so on. Your a value is going to flip it upside down or make it wider or less wide. So as you tinker with these numbers, it will go over and shift it. A way that you guys study it in Algebra 2 is y equals x squared is your parent function. And I'm fairly confident, if I'm remembering this correctly, that one of the forms that you're going to look at in Algebra 2 is going to be a times x minus h, that's an h, not a b, squared plus k. And how that works is that h comma k is going to be your vertex. This is called vertex form. And it basically teaches you how to shift around your figure. So once again, there is a form that describes a quadratic, and as you tinker with the numbers on the inside, it shifts it left, right, up, down, flips upside down, and does stuff like that. Any questions? The next one is y equals absolute value of x is your basic absolute value function. It's going to look like this. Here, these numbers will shift it left, right, up, down, make it flip upside down. It'll do different things based off of which one of these numbers you are changing. So that's for absolute values. Does anybody have any questions on that? So what we're going to do is we're going to come up with a form for circles, and we're going to learn it. What are the numbers that you would change to shift it left, right, up, down, figure out what the center is, figure out what the radius is. And all of that is based off of this. The locus definition is all points equidistant from a point on a plane. So let's go ahead and develop the formula. The formula for distance is the same as the Pythagorean theorem, and the equation of a circle is the same as both of those things. So go ahead and let's label these points. Let's call this x1, y1, x2, and y2. We know distance formula is d equals the square root of x2 minus x1 squared plus y2 minus y1, it's a minus in there, y2 minus y1 squared. That is that karate rabbit that I taught you guys. All right, let's adapt it for a circle. What is d in the circle?
The radius.
The radius, r. Put a square root. What is the thing that we already identified as x2? Which one is it? Look at our diagram. Which one is x2? No, it's x1. It's going to be, which? It's just x. So x. Then by default, you have a minus here. Now, what did we define to be x1? H, which is the x part of our center. And then you put a squared, then you put a plus. What is y2?
Y.
And then minus, and then what is y1?
Okay.
Squared. Technically, that is also the equation of a circle. We just don't like square roots. So how are we going to get rid of this square root? Square it. Square that side and square that side, and there is your equation of a circle. You're going to have x minus h squared plus y minus k squared, and you have the equation of the circle. Let me show you an example. Maybe you have 100 equals x minus 5 squared plus y plus 7 squared. Let's figure out what that actually means. These are by default minuses. So minus actually means plus, and plus actually means minus. So what is the center, looking at this part right here, what is the center of this example circle right here? It's the opposite of what you would assume. So where is the center? Close. Remember, it's x comma y for a point. Okay, so this means that your center is at 5 comma 7. 5 comma negative 7. Does anybody have any questions about why this would mean 5 negative 7? Next, we have a 100 here, which is representing the radius if it was squared. So what would be the radius of this circle? If 100 represents the radius after it's been squared, then what is the actual radius? 10. There you go. So just like with a line, you can say, oh, I know the y-intercept is 1, and we go up 2 over 1. It gives you like instructions. This is also instructions. This tells you the x part of your point, but it's the opposite of what you'd assume. The y part of your point, which is the center, the opposite of what you would assume, and then you square root this number, and that gives you the radius. That's most of the lesson. Questions? Okay, let's go ahead and do one together, and then I'll have you guys do too. So on here, we're going to put an x, and then we're going to put a minus by default. And then we put the x coordinate. What is the x coordinate of the center? 2. And then I put a squared, and then I put a plus, and then I put a y. By default, a minus.
5.
5 is the y coordinate. We finish it up, put a squared, equals. Now what goes over here is not just the radius, but the radius squared. So it's either 49, or if you want to be nice to the person that is going to read it later, you can leave it as 7 squared. That way the person can easily see center of 2 comma 5, radius of 7. They don't even have to square root it. Does anybody have any questions on that? None? People at home, pause the video. I want you to try 2 and 3. People in class, do 2 and 3. All right, looks like most of the kiddos in class got these right. X minus the x coordinate squared plus y minus the y coordinate squared equals the radius squared. You can make this into plus if you would like, and you can go over and square that if you would like. Just in this form right now, I probably would change this to be plus, just because I don't like minus negatives, but I probably would not go over and square that. On the other one, you have x minus 0 squared plus y minus 1 squared equals 5 rad 3 parentheses squared. Just making sure that you know that you're squaring both of them. If you actually squared both of them, that would give you 5 squared is 25, rad 3 times rad 3 is 3, and you would have gotten 75. Do you need to have x minus 0? No, you could just have x squared. Is that your question?
Yeah.
Great. Does anybody have any questions on that? Okay, next one. Now I want you to be able to see the equation and identify the different parts. So on this one, let's see, who do I want to call on? Initials, GC. What is going to be the radius on here? What's the radius? It's 8. It's not 64. It's 8. Now, when I make it a big number like this, like 64, it's highly unlikely you're going to forget to square root it. On the test, I'm going to give you a number like 4, so you'll actually have to remember to square root it, where 4 on its own seems like it would be fine. And same student, what would be the center? So remember, it's the opposite of what you would assume. -2, comma 6. Okay, this is like this really interesting thing because it actually shows up in a lot of other applications. Like if you have y equals the absolute value of x plus 5 on here, I'm pretty sure that you would assume means that you are going to go right by 5, take your v, and go right by 5. I'm almost positive that it actually means the exact opposite of that, which is left by 5. I'm actually going to just test it because I don't like forgetting things. If I put in 0 for I don't want 0 for x. Let's put 0 for x. That would give me 0 comma 5. I'll look into it in a second, but I'm almost positive that that means the exact opposite, just like this means the exact opposite and opposite. Okay, next one. The radius. What is the radius going to be? mm? 6, fantastic. And what is going to be the center? Great. Does anybody need me to do that last problem? No? So on here, this actually means 9. So if that's 9, then what does that mean for a radius? 3. And then you'd have 0 comma -9. Any questions? No? Okay. Let's go ahead and look at this one right here. This is a slight variation. We can already see that our center is 2, -3, and our radius. Okay, just remember, counting diagonally is not easy. Counting up or down or left or right is very easy. So in this case, what is going to be our radius? 1, 2, 3, 4. So we have a radius of 4. So if you're given the circle, just find out what the radius is, find out the center, and then stick it into your formula. X minus the x coordinate squared plus y minus the y coordinate minus -3 is actually plus 3 squared equals 4 squared. Anybody have any questions to that? None? In that case, I want you guys to go ahead at home, pause the video, and do these 3 problems. People in class, do these 3 problems. Be very careful though. Look, each one of the tick marks is actually 2. If you don't realize that that is going by 2s, all of your answers are going to be incorrect. So this goes 2, 4, 6, 8. It does not go 1, 2, 3, 4. All right, people at home, pause the video, write these equations. All right, for the first one, it had a center of 16, 10, so that's how I got my -16 and -10. It had a radius of 10, so that's how I got my 10 squared. The next one had a center of 4, 20, and that's how I got the left side, and then it had a radius of 10, that's how I got the right side. Yep.
Wait, wouldn't the radius be 5?
So I think that you are counting by 1s, it's actually by 2s. Does that make sense? Okay. And then the last one has a center of 0, 0, and a radius of 12. Questions? All right. The next part is just graphing them. So let's go ahead and do that first one. You need to know where the center is, and you need to know the radius, and then once you have those things, you can make your circle. So on this one, Blair Bear, what's going to be my center? Comma. Good. And then what's my radius going to be? Cool. So what we're going to do here is we got to go to 2, 0. 2, 0 is right here. Now, any diagonal length of 6 is a nightmare. So what I do is I go up by 6. I go down by 6. I go right by 6. I go left by 6. And now that you have all those points, then you wing kind of the rest of the circle. Or if you have a compass, you can do it nicely. Anybody have any questions on that? We have this second problem that we can do if you guys need a little extra practice. If not, we can skip it. Any questions about what the center would have been on this or what the radius would have been? -3, 1, and a radius of 3. Up 3, down 3, left 3, right 3. Okay, the reason why we could skip that is because we're doing something that's very, very similar to that. But now, what are you noticing on problem number 3 that's different than what we just did?
It's not an equal sign.
It's not an equal sign, it's an equality sign. So let's just graph it as if it was an equal sign first, and then, do you guys remember you always shade when you have the inequality signs, symbols? So let's go ahead and do this. This means a center of -3, 1 with a radius of 4. -3, 1 is right here. I'm going to go up by 1, 2, 3, 4, down by 4, right by 4, left by 4. 1, 2, 3, 4. Now you have to bring yourself back to your algebra class and remember, is that dotted or solid? If it does not have the equal sign, is it dotted or solid? Dotted. So what you're going to do is now put a dotted line or a dotted curve.
How do I like find all the radiuses if like the numbers and stuff are like blocking the way?
I just counted. So I counted the tick marks. Okay, now you are either going to shade inside or outside. Either all of those points, the numbers on the inside are solutions, or the outsides are solutions. So you get to pick any point you want that is not on the curve. If the point works, shade in there. If it does not work, then shade the other side. You get to choose whatever you want. It does not matter. So what point seems like a point you would want to try? Okay, 0, 0 is what I like to try a lot. A kid last period had a really good idea. They said, why don't we just use the center? Because when you put the center in, it actually makes inside the parentheses 0 for both of them, which is kind of cool. So I think I might do that. So if I put in -3, I've been doing 0, 0 always because that's what I did in Algebra 1. But if you put in -3 plus 3, that gives you 0. And if you do 1 minus 1, that gives you 0, which is nice. So the center is always going to make that be 0. So you would end up with 16 is less than 0. Is 16 less than 0? No. And for some reason, this is always the thing that confuses people. That means that the center is not allowed to be shaded. Shaded means, hey, these are all solutions. So if the center's not going to be shaded, then nothing on the inside can be. And that just means that all of the outside needs to be shaded.
So if it was the center, why wasn't it like -3?
Because remember, the center is actually the opposite of what you would assume. The center is not 3, -1. It's -3, +1. It's the opposite of those numbers. Does that make sense? Does anybody have any questions on that? Okay, the next one. You got, yeah? I don't know. A kid just asked that. Can we always say that less than means inside and greater than means outside? I don't know. I've never looked into that. I'm not 100% sure. Not only that, but if you switch the sides, if the 16 is on the right-hand side, now the less than symbol means something different. Does that make sense? Yeah, it's going to have to switch too. But then I have to tell the kids, well, if the number's on the left and it's a less than symbol, then shade here. It just gets too confusing. I see what you're saying. I don't know. Yeah, I don't know. I always just test the point. Okay. All right, let's do the next one. We know that this is going to be the point -2, 0. Does everybody agree with that? And someone needs to square root 28. I don't know what that is, like 5 point something. 5.3. About?
5.3.
Okay, cool. So let's go to -2, -2, 0, and then let's go up by 5 point something, 5.3, down by 5.3. Right by 5.3. Left by 5.3. Is it going to be dotted or solid?
Solid.
It's greater than or equal to. So that means it's going to be solid. Now, once again, you can pick any point you want. I know the center point will make both of them zeros, which is kind of cool. So I'm going to go over and just use the center point. So that's going to be 28 is greater than or equal to. That gives me a 0 squared plus 0 squared is just 0. Is 28 greater than 0 or equal to 0? Is 28 greater than 0?
Mm-mm.
Yeah, it is 28 bigger. I got 28 bucks. You got nothing. I have more than you. Okay, so that means that this little guy right here needs to be shaded. The only way he can be shaded is if everything in here is shaded. Okay, so you are probably right. You are probably able to say if this number is, if you always have the radius on the left greater than means inside. My only concern here is look where the center is on both these. They're both really close to the same point. I'm curious if that'd be correct if you went over and had the radius like over in this other quadrant. It's probably true that if it is greater than, it's going to be inside. If it's less than, it's outside. But I'm not 100% sure. In the scope of this class for this next 8 minutes, I can't take the time to take a look at that. We can look at it later, though. All right, anybody have any questions on how to do that? Yes.
The 28 always squared. Can it ever be negative?
Good question. Fantastic question. Could we ever have a negative number on the other side? Not in real numbers. You guys are going to study imaginary numbers next year. When we ever got like the square root of -49, we said, oh, no real numbers or something like that. That can technically be made into -1 and 49. The square root of 49 gives you 7, and they define the square root of -1 to equal I later on. So you will learn how to make this into, oh, the square root of -49 is 7i. So you can kind of think of it that way, but for our class, we're not going to have a negative number over there. Great question. All right, we got a few more minutes, and we need to do these algebra-based problems. This problem says that we have the center, and we have a point on the circle, but we don't have the radius. So we can start out by writing the equation as x minus 2 squared plus y minus 5 squared. We just don't know the radius. Any ideas on how we can find that radius? Distance formula, great job. I always label them because otherwise I mess them up and it only takes like 2 seconds. Square root of 5 minus 2 squared plus 9 minus 5 squared. 3 squared plus 4 squared. 9 plus 16. 25. So if that's giving me a radius of 5, then what are we going to have on this other side? 25 or 5 squared, doesn't matter. Does anybody have any questions about why I had to use the distance formula? None? Okay, the second problem is just like the first. So let's go to number 3. Number 3 says you have one endpoint of the diameter and the other endpoint of the diameter. What is the equation? Now we have 5 minutes left in class. I want you guys to talk to at least one other person in this class and come up with a plan. Rather than me just telling you how to do it, come up with a plan and I'll be back with you in a second. People at home, pause the video and try to come up with a plan of how you're going to come up with the equation. All right, the two things that you need for the equation is the center and you need the radius. What formula are you going to use to find the center? Midpoint formula. Fantastic. What formula are you going to use to do the radius? Distance. Fantastic. So let's go ahead and do both of those formulas. You can see the midpoint is the center. So we're going to have the midpoint being 1 plus 7 divided by 2 and 5 plus 13 divided by 2. 8 over 2, 18 over 2. 4, 9. So we can already get to the x minus 4 squared plus y minus 9 squared. We just now need the radius. There's many ways to do this. One way is if I found the distance between these two, that gives me the diameter. So what would we have to do then? Divide by 2. Or we can take the point which we just learned, 4, 9, and we can find the distance between those two or these two. Me personally, I'm going to go straight to the radius, and I'm going to do those 2 points because they are small. 1, 5 and 7, 13. x1, y1, x2, y2. Square root of 13, what the? Nope. Doop, doop, doop. 7 minus 1. Am I doing something wrong here? What am I doing? Yeah, okay, so I said that I was doing center and I was going straight to the radius, but then I went over and I did the diameter. Okay, oops. Well, now that I already have it written out, I'm actually going to do the diameter and then I'll divide by 2. So 7 minus 1 squared plus 13 minus 5 squared, 6 squared plus, what does that give me, 8 squared? 36 plus 64, square root of 100 is 10. So once again, I said I was going to do the radius, then for some reason I wasn't thinking, and I put the points for the diameter. So this is the diameter is 10, so the radius equals what? 5. Therefore, what do we put on this side? 5 squared or 25. Does anybody have any questions? All right, thanks so much for watching at home. Bye.